Marking is the first and most crucial step in the major garbage collection cycle. In this video, we will discuss in detail about the naive approach to the marking process. Hi, I am Rohan and this video is part of a series of videos where we are exploring how JS manages its memory in detail. So let's get to it. Let's talk about major garbage collection. This is responsible for garbage collection of the entire heap. It utilizes a process known as mark, sweep and compact. We will discuss each of them individually and then put it all together. The marking phase is responsible for marking all of the objects in the entire heap as either live or a dead object. But what makes the garbage collector decide if an object is alive or dead? Basically, if the garbage collector can reach an object, it is considered as alive. Otherwise, the objects are considered as dead objects and can be deallocated. This concept is known as reachability. Let's take an example where we create an object called personal info. In this object, we have two object properties called profile and personal. The profile object further contains two more objects called name and contact. The personal object contains two object properties called birth and address, and the birth object contains two more object properties called date and place. So when we create this personal info object, then all the objects that are within this nested objects are allocated in the heap and they are interconnected via references. As a result, they are reachable from the root node. Now, at some point in time, we set birth equal to null. So the node birth along with its subnodes date and place are now unreachable from the root node. We also set personalinfo.profile.name equal to null, hence removing the reference to this object and making it unreachable. But where does the garbage collector start? It has to start from any non-heap references. What do I mean by that? Any references that are found outside of the heap are considered to be our starting point. These references to the nodes or objects are known as roots, and this includes the global object, which is window in case of browser and global in case of Node.js, along with references that are found in stack memory. Now, let's start with the marking process algorithm itself. The garbage collector has to traverse through an entire graph of objects. The starting point, of course, is the references that are found in the execution stack along with the global object references. Using these references, we can access the root nodes. Once it has all the root nodes, then it will start marking the nodes using an algorithm that is known as recursive depth first search algorithm. Let's consider this entire process as a function called mark nodes, which will accept a parameter that is a list of nodes. So this function will be called using roots. Once it is called, we enter into the function. A while loop will check if nodes is defined and if it has some items in it or not. If this condition holds true, then it will enter inside the while loop. Once it does, then it will pop a node out of the nodes list and check if the node is defined or not and if it is marked or not. So if this is not marked, then it will enter into the if condition and the node will be marked and get all the references to the other subnodes that are contained within this node. Using these subnodes, it calls mark nodes function recursively, and the entire process will repeat for all the subnodes, its subnodes and so on until it reaches a node that does not contain any references. Then it won't enter into the while loop and the function will end. If you visualize that each of these references are branches, then it will traverse through each one of these branches and mark all the nodes that are reachable. And if a node is already marked, then it won't enter into the if condition and it will move on to the next node in the list. This scenario, by the way, can happen in cases of circular references, meaning that node A is pointing to node B and node B is pointing to node A. Similarly, each root node will be picked up from the list, marked, and then its references to the nodes will be used to mark all the nodes, then its subnodes and so on until all the roots are used to mark all the reachable objects, and then the algorithm will end. Let's reuse the same personal info object example in which we have a nested object but we remove the references to birth and name objects. So the marking process starts. Personal info object itself is picked up and marked being the root node. Then the references that it contains is picked up. So profile is picked and marked. And after that, we pick up all the references that are within profile. There is only one reference in this case, that is pointing to contact, which is then picked and marked. After this, The reference to personal object is picked, so it is marked, and then the reference within it is used to mark address. Hence, all the reachable nodes are now marked using this process, and the unreachable nodes are considered to be dead objects. Let's look at another example. But in this example, we have lots of circular references. In this example, we have a class called position, which will contain properties name, which will act as an identifier, and other properties called left, right, up and down, which contains references to other objects. We will create 9 objects using this class from A to I and create a grid of 3 cross 3 by connecting each of these objects using the properties left, right, up and down, and the references between the sibling objects goes both ways, which means that A has a reference to B using down property and B has a reference to A using up property. So all the objects are created, the references are updated, and the memory is allocated in the heap. Now at some point in time, the marking process starts. The variables A to I are considered as roots, so the marking function is called with a list containing them. So each one of them is picked and marked. Then the algorithm picks up one of the references within this object and then traverses to other connected objects one by one and marks them. And since checking if an object is already marked or not is one of the conditions, the algorithm bypasses the circular references problem. Finally, all the objects are marked successfully and the algorithm ends. Let's create the facsimile of the marking algorithm by creating a JavaScript function. This will be a recursive function which will accept a list of nodes. It will iterate through the list one by one, mark each one of the nodes, log it, and then traverse to other connected nodes using the references. Let's execute this function by calling it with variable A and see the results. As you can see, the function has successfully traversed through all the nodes and logged them once. Now, I have to confess that the algorithm that we have discussed for marking is important to understand the basics, but it has now become obsolete. This algorithm is known as naive approach. This is because when the marking process is in operation, then the main process stops, and this causes a few problems, especially in big applications. So when the heap becomes full and the garbage collection process starts, then it marks a huge graph of objects. After that, sweeping and compaction happens, and this complete process is shown to be as long as several hundred milliseconds, as much as half a second, especially in mobile phones. And this will become noticeable since every time this happens, the main application would pause. Another issue is that this algorithm is not designed to work in parallel to our main process. To solve these issues, V8 is now utilizing another algorithm called tricolor marking. To summarize, we discussed what marking process is and how the garbage collector differentiates between live and dead objects. How the links between the objects are used to mark all the live ones. We discussed the marking process in detail, and we also looked at a couple of examples to visualize how the process actually works. Additionally, we briefly discussed the limitations of the naive approach and a need for a different, better algorithm, the tricolor marking algorithm. And this is what we will discuss in the next video. Thank you for your time. Have a nice day. Namaskar.